First proof, I've placed the triangle for you. And so we just want to do the proof to show that the triangles are congruent. One way, let's use the distance formula. And let's start with FG. So to find the distance from F to G, I'm going to say A minus 0 squared. Well, that'll be A squared. Whoops, need a pen there. So A squared plus B minus B over 2, well, that will be B over 2. Because a whole minus a half is a half. So that'll be A squared plus B squared over 4. And there we have it. Now let's do the same thing for F to D. Why did I choose F to D? Because I notice it corresponds with F to G. So F to D now, whoops, hate it when it does that. Okay, so I'm going to do F to D. 0 minus A squared, well, that'll be negative A squared. B minus B over 2 minus B would be negative B over 2 squared. When I square a negative, I get a positive. It's A squared plus B squared over 4. Notice FG and FD, they're congruent. Okay, let's do FH. And once again, I want to do F to H. So F to H is A minus 0, so that's A squared, plus 0 minus B over 2, so that's negative B over 2. Oh, look at that. I get A squared plus B squared over 4. Not only are these two triangles, not am I trying to prove these two triangles congruent, I know at least one of them is isosceles. And let's do FC then. And let's see if that turns out any different. So now we're going to go F to C. 0 minus a negative A is positive A squared. B over 2 minus 0 is B over 2 squared. So we get A squared plus B squared over 4. So I've got two isosceles triangles. I just need my third sides. So let's find the distance from H to G. Or GH, I'll say. Now the nice thing, notice GH, it's a vertical line, isn't it? That distance is B. And then what happens when I do DC? That distance is B. Because, once again, my x-coordinates are the same. So I can say these two triangles are congruent by side, side, side. Now, if you're asking yourself, hey, could I have done this differently? Sure, you could have. I had vertical angles. I could have used side angle side. I had parallel lines, so I had alternate interior angles. I had a whole bunch of different ways of doing it in this case. I just happened to choose side, side, side on this one. Now, to show two lines are parallel, remember, we're given the same slope. So if I got this coordinate proof, my equidistant, that doesn't really help me do my proof. I'm just going to go back to my basics. I'm going to find the slope of AB because I'm trying to show parallel. So my slope of AB, and notice with one coordinate being 0, 0, it gets pretty simple. It's B over A. It's B minus 0 over A minus 0. So my slope of AB is B over A. Now let's turn around and let's do the slope of CD. Don't have to do too much different here. So I'm just going to look at 2A comma B and A comma 0. So if I subtract my y's, it'll be B minus 0, which is B, over 2A minus A. Maybe I'll write the 0 in there just to be safe. So B over A, same slope. So AB is parallel to CD because they have the same slope.